For many years following the first test of an atomic bomb in 1945, the most common method of testing experimental nuclear devices was to detonate them from the top of steel towers, whose height varied from 300 to 700 feet, depending on the expected yield. In 1957, the Lawrence Livermore Laboratory demonstrated the feasibility of underground testing by detonating a nuclear device emplaced at the end of a tunnel driven horizontally into a mountain at Nevada. This same test series also included the successful demonstration of helium-filled balloons for elevating an experimental package to the desired altitude for detonation. In 1958, the Los Alamos Scientific Laboratory conceived and developed the use of deep vertical drill holes. This highly successful technique, improved through the years by both laboratories, constitutes the standard method of underground testing today. The AEC's Pacific Proving Grounds at the Eniwetok Atoll were used to conduct tests in the atmosphere of high-yield devices. In addition to steel towers, special barges were outfitted and towed to remote locations in the lagoon. In all of these methods, by fixing the exact position of a test device, scientists could perform sophisticated diagnostic experiments to closely document the time history of the nuclear reaction. Although military aircraft had been used previously for conducting low-altitude airburst nuclear events, in those tests, the prime technical mission was to study various effects from an explosion. Because of the urgency to resume large-scale testing, in the Dominic series, it was decided to employ the aircraft release mode for the low-altitude test program and ground-launched missiles for the high-altitude experiments. In 1962, by joint agreement between the President and the Prime Minister, Operation Dominic was held at the British nuclear test site in the Christmas Island Atoll. This area was selected due to political complications arising during the moratorium, which prevented the United States from using the Atomic Energy Commission's Pacific Proving Grounds at the Eniwetok Atoll. Christmas Island, the main camp of the British nuclear test site, was located 1,200 miles south of Honolulu and 120 miles above the equator. This island has a total land area of 160 square miles, with an average elevation of 15 feet above sea level. The remote station primarily served as refueling and air-sea rescue support for British commercial and military activities in the Pacific Theater. The United Kingdom had last conducted nuclear tests there from 1956 to 1958, but little remained of their support facilities. Administered by a British district commissioner, the base included elements of the Royal Air Force, Navy, and engineers. In the Dominic series, the British provided general support and fielded some of their own instrumentation, but did not conduct any weapons tests. An unusual aspect of this operation was that it was the only oceanic nuclear test series conducted by the United States, where the local inhabitants were not evacuated, but allowed to remain and witness the detonations. When the construction program to build the various support facilities was completed, scientific personnel from the various agencies participating arrived to prepare for the operation. In Operation Dominic, General Starbird of the United States Army served as commander of Joint Task Force 8. His staff included various other representatives of the armed forces. Serving as the overall director of scientific activities for the Joint Task Force was Dr. William Ogle of the Los Alamos Scientific Laboratory, a veteran of nuclear testing. Assisting him were Dr. Robert Geckerman for Livermore Technical Programs and Dr. Austin McGuire for the Los Alamos operations. On arrival, all civilian and military personnel were briefed by the British so that all local regulations would be clearly understood, including driving on the left side of the roads. Since the AEC's major weapon laboratories had considerable experience at the Eniwetok and Bikini atolls in deploying mobile laboratories for field diagnostics, the transfer of their special trailers did not constitute any unusual logistical challenge. As the island had no natural harbor, the vans and equipment were transported by cargo ships to the northwest end of the island, where they were offloaded by landing craft and taken to a special security compound in the main scientific camp, which was called A Site. In addition to diagnostic apparatus, other field facilities included office trailers, electronic maintenance shops, machine tool and mechanical shops, weather and communications equipment, and photographic laboratories. As high as 300 participants from the scientific laboratories were housed at the A-Site camp. In addition to the canvas tents for lodging, which accommodated 8 men each, other basic needs were provided. In the Hawaiian Islands, the Barbers Point Naval Air Station at Oahu played a key role in the Joint Task Force 8 operations and served as the takeoff point for the delivery aircraft. A field operations group from Livermore was established and staffed in Hawaii to coordinate the movement of laboratory personnel and equipment between the states and the various field stations. The Military Air Transport Service served as the main carrier between Honolulu and Christmas Island. Final assembly of all nuclear devices was performed by scientists and engineers from the weapons laboratories at Barbers Point. They would then be installed in a military universal test vehicle and stored in nearby igloos, normally used for naval ordnance, until shot day approached. Two B-52 bombers were used alternately for the low-altitude drop tests at Christmas Island, which included both stockpile weapons verification and new device development experimentation. In the airdrop delivery mode, a device was loaded at Hawaii and flown south to the Christmas Atoll. There, at a prefixed point several miles from the land-based instrumented stations, the device would be dropped. With its mission complete, the aircraft would then return to Hawaii. The Sandia Corporation was responsible for the fusing and arming functions of all nuclear devices, while the EG&G organization directed the timing and firing functions. Normally, the device would be loaded on the aircraft the day before the shot date. If the weather was unfavorable, the test would be postponed on a day-to-day basis. Back at the A-Site scientific camp on Christmas Island, Livermore researchers calibrated their diagnostic instruments for each nuclear event. Their task was to measure the time history of the air fluorescence induced by the neutrons and gamma rays emitted during the earliest stage of an explosion. Data measurements were collected by 3 major diagnostic methods: optical detectors, electromagnetic sensors, and high-speed streaking cameras. If during a final run a clear line of sight to the surface target point was not secured because of local cloud cover, the run would be aborted and another approach undertaken. When the bombardier was on target, the bomb was separated from the aircraft, initiating a final 30-second countdown to 0 time. Timing signals were emitted from the descending drop vehicle to data collecting stations to ensure that all instruments would be operating at the precise moment of detonation. The most valuable weapon physics information is secured within the first few millionths of a second. The initial light flash is caused by the air fluorescing from the neutrons and gamma rays being emitted. This light production mechanism is known as teller light. Because of the extremely short duration of the camera exposure, in daylight, the sky appears dark. During the next few thousandths of a second, the fireball expanded rapidly. This phase of the reaction was observed primarily by the EG&G organization with high-speed framing cameras. Interpretation of these data enabled scientists to calculate the yield of a nuclear event. As witnessed by an observer at the test site, when a device was triggered, a complete whiteout occurred. Personnel present wore high-density goggles to prevent eye damage. The duration of the extreme brightness would vary according to the yield of an explosion. As the bright light diminished, the nuclear cloud would begin to form. This fiery red turbulence stage was the most spectacular phase and could be observed without goggles. Experimental nuclear devices designed by the Livermore Laboratory were normally tested in the pre-sunrise light to maximize the recovery of data from diagnostic light sensors. This particular LLL device, however, was detonated in daylight, which enabled motion picture cameras to observe the continuous development of a nuclear cloud. In the airdrop mode, the devices were exploded at an altitude of about 10,000 feet, about 15 to 30 miles from Christmas Island, depending on the expected yield of the nuclear device. In the first 6 to 8 minutes, the cloud would rise vertically as a whole, after which it would stabilize and be dispersed according to the wind direction at various altitudes. Another major diagnostic means to measure the performance of a nuclear test device was radiochemical analysis of debris collected from the nuclear cloud. In this operation, as in earlier tests, the British-designed B-57 Canberra aircraft was used because of its overall adaptability for sampling missions, and in particular, its ability to reach altitudes over 60,000 feet. Based on the observation of the sampling aircraft crews, most nuclear clouds seem to level out at about 65,000 feet, with bottoms in the region of 35,000 feet, regardless of yield. It usually took about 8 minutes for a cloud to top out. The sampling aircraft for the low-altitude tests were stationed at the Christmas Island airstrip, which included a special recovery pad called the Hotline. All Air Force radiological personnel were outfitted with radiation safety clothing to minimize exposure from the contaminated aircraft. After every mission, each plane would be thoroughly cleaned at the nearby decontamination pad. Some air samples were collected in these special gas bottles, which were mounted on the aircraft. All aircraft had special pods at the tip of each wing that contained filters. When a cloud penetration was made, a valve would be opened to permit the capture of cloud debris. The radioactive filters were carefully removed from the pods and inserted into 3-inch heavily shielded containers nicknamed lead caskets. All pilots and recovery personnel participating in the air sampling program were closely monitored over the duration of the operation to ensure that their accumulated dosage did not exceed prescribed limitations. All samples from LLL devices were flown immediately back to Livermore for detailed radiochemical analysis of the short-lived isotopes. During the Dominic series at Christmas Island, field personnel from the Livermore Laboratory maintained a 54-hour work week. However, Sundays were always reserved for recreation and relaxation. Especially popular were beach parties held at different sites on the island. Many aspects of the tropical environment were fascinating, such as the bird life. This particular gannet bird exhibited no fear of Livermore official photographers. The warm tropical atmosphere of the islands was very conducive to outdoor activities, such as fishing, surfing, or just collecting seashells. camaraderie developed at these beach parties nurtured many a lasting friendship and made the long absences from homes and families more tolerable. Although the active phase of the ambitious test series extended almost 6 months, most personnel were rotated or replaced at shorter intervals. The successful development of land-launched rockets for nuclear cloud sampling at the Nevada test site in 1959 resulted in their being selected for expanded use in Operation Dominic. The rocket vehicle consisted of a 2-stage solid propellant and a payload section that included a nuclear debris collector, flight programmer, and a recovery package. Although manned aircraft sampling missions were the most flexible and widely applied method of recovering nuclear cloud samples, some limitations were evident. Because of personal safety, early cloud samples could not be obtained, and clouds from high-yield explosions were nearly out of the altitude range of the sampling aircraft. Launched at 5-second intervals, the rockets would follow a ballistic path for 75 seconds before their parachute-retarded descent. Impact points at sea would be obtained by tracking the package by radar. In Operation Dominic, the use of rocket sampling techniques enabled scientists to collect the earliest cloud samples ever recovered during atmospheric testing. An important phase of the Dominic test series was a number of high-altitude nuclear events conducted near Johnston Island, southwest of Hawaii. Unlike the use of aircraft for the low-altitude airdrops, these nuclear devices were delivered to their upper atmosphere burst points via land-launched missiles. The Thor missile was selected as the prime launch vehicle for the events because of its ability to attain the high altitudes carrying 3 1,200-pound heavily instrumented pods. The purpose of the high-altitude program was to assess the multitude of effects from a nuclear explosion occurring in the upper atmosphere. Although the tests were primarily for the Department of Defense, scientists from Livermore provided diagnostic support. Each of the pod modules mounted on the Thor missiles were outfitted with a wide variety of measurement devices, such as accelerometers, pressure gauges, and numerous metallurgical samples. To obtain a wide range of information, 5 devices were detonated at different altitudes, ranging from 13 miles to 250 miles above the Earth's surface. A large number of land-based data gathering stations and especially outfitted airborne diagnostic laboratories also participated in the unusual experiments. In addition to diagnostic equipment mounted on the Thor missile, land-based rockets were used to launch a large number of diagnostic instruments to the detonation zone. Because of the much higher burst altitude compared to the lower altitude events conducted at Christmas Island, the more powerful Nike Apache rocket systems were employed. In addition to the rocket stations on Johnston Island, similar rocket-borne instruments were launched from a firing site at Kauai in the Hawaiian Islands. Engineers from the Sandia Corporation worked closely with the Livermore researchers to execute the successful high-altitude sampling missions. From the high-altitude events which completed the Dominic series in November of 1962, a profusion of technical data was gathered. This data, when later reduced to meaningful analysis, provided a firm foundation for evaluating the effectiveness of a nuclear blackout, such as a penetration aid for ballistic missiles, the effects of high-altitude burst on radio communication links and navigational systems, and the effects on guidance systems. In addition to the low and high altitude test programs, additional nuclear operational system tests were successfully conducted, including an anti-submarine weapon system and the Polaris submarine launched missile, which contained the LLL-designed W-47 warhead. In October of 1963, the Limited Test Ban Treaty between the Soviet Union and the United States was ratified, barring the testing of nuclear weapons in the atmosphere and limiting tests to deep underground emplacements. Consequently, from a historical perspective, Operation Dominic would be the last major U.S. test series in which nuclear tests were conducted in the atmosphere. By observing highlights of the 1962 test series, it is hoped that viewers will gain greater understanding of the extensive field operations and unique diagnostic methods utilized during the era of atmospheric testing.